Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the June 2020 International A-Level Pure Mathematics P2 Edexcel paper, and this question is about logarithms. It's a slightly different style of question that you might be used to, but it's pretty simple. Basically, you've got two equations. One of them is in the form of like a minus b equals 0. A and b are positive constants here, and you've got another equation which we have to solve simultaneously with the first one, where you've got a and b in terms of log to the base 4. So of course, for us to solve a question like this, what we need to do is to convert them both into the same form. Now, the easiest thing for us to do here would be for us to take this log to the base 4a plus log to the base 4b equals 3 and convert this into a normal number. So what we have to do here is we have to combine the two logs together. They have the same base, so it's pretty simple. We just use the law of logarithms with addition, where we have to combine these together as a product. So we say log to the base 4 of a times b is equal to 3. All right, that's how we can just rewrite this equation, combine these into one logarithm. And then we use the fact that the log to the base a of b equals c can be rewritten in index form as this is the base, this is the power, and this is the result. A to the power of c equals b. So in this case, we're going to have 4 to the power of 3 is equal to AB. So therefore we can say AB is equal to 4 cubed, which is 64. So basically we have these two equations. We have A minus B equals 8 and A times B equals 64. Equation 1, equation 2. These are the equations I have to solve simultaneously, and I can do that by using some sort of substitution. For example, I can take equation 1 and I can express A in terms of B. For example, I can say A is equal to, if I add B to both sides, b plus 8, and then I can substitute that into this equation, replace the a with b plus 8. So I have b plus 8 times b equals 64. I could have done the same thing with a. I could have written down a equals, I could have put b equals a minus 8 and done the same thing. So now we end up with b squared plus 8b minus 64 equals 0, because it's going to be quadratic. So we can solve it by equating it to 0 and using the zero product property. Now the question says you must show all stages of your working and give your answers in fully simplified surd form. So that's a clue to me that most probably this will not be able to be factorized, and I don't think we can find two numbers that multiply to give you negative 64 and they add up to 8. They both have to have different signs. You've got 16 times 4, that gives you 12 when you add them together in different signs. I don't think there's any way of doing it, and what kind of confirms that to me is this statement here: simply give your answers in fully simplified surd form. So I'm not going to bother trying to factorize this. What I will do is we can either complete the square, or we could use a quadratic formula. I think this looks pretty simple to complete the square with. So what I do when I'm solving a quadratic equation using completing the square, I like to isolate the b squared and b term, or the letter term on one side, and the constant on the other side. So I add 64 to both sides, and then I'm going to complete the square for this. So I have a square bracket. I'm going to have b, this is a plus, I'll put plus, and then a half of the coefficient of this number, so that's 4. If I expand that, I'm going to get b squared plus 8b, but then I'm going to get plus 16, so I've got to take away the 16 from this, and I end up with my, this simplifies so that this b squared plus 8b is the same as b plus 4 all squared minus 16. If I expand this, I'm going to get b squared plus 8b plus 16 minus 16. They cancel, and you're left with b squared plus 8b. Now I can solve this because I've got this square bracket. I can add 16 to both sides. So I have b plus 4 squared is equal to 64 plus 16. That's 64. 74 plus 6, that's 80. Okay, so now I can say b plus 4 is equal to positive or negative the square root of 80. Okay, and 80 can be simplified. I think 80 is 16 times 5. We've got a perfect square. Now, when I want to simplify this, you could use your calculator to do it, I guess. But, for understanding how to split up this, You know, you got a perfect square. You're going to try and split it up into perfect square factors. Now, I could have tried 4 and 20, but 20 still has a perfect square in it. So you look for the biggest perfect square you can find, biggest perfect square factor, which is 16. 16 times 5 is 80. That's the biggest perfect square you can find. So you're going to end up with plus or minus. Now, the square root of 16 is 4. So it's 4 times root 5. So the square root of 80 is the same as the square root of 16 times 5, which is the same as the square root of 16 times the square root of 5, which is 4 times root 5. That's how I got that. So we can say b is equal to minus 4 plus or minus 4 root 5. Now the question tells us that a and b are positive constants. Okay, a and b are positive constants. And if I do minus 4 root 5, now 4 root 5 is going to be a magnitude bigger than 4. So if I do minus 4 root 5, I'm going to end up with a negative answer. Anyway, if I subtract something from negative 4, it's going to be negative anyway, no matter what it is. And minus 4 plus 4 root 5, that's going to be, the magnitude that's going to be bigger than minus 4, so that's going to give us something positive. So therefore we can say b is equal to minus 4 plus 4 root 5. It can't be the negative part. Only this. So that's b. Okay, so that's the value of b. And we can find the value of a by simply using one of these two equations. I think the first equation is easier. If you have a minus b is equal to 8, so we can say that a is equal to b plus 8. So a is equal to minus 4 plus 4 root 5 plus 8. So we have minus 4 plus 8 is 4, so 4 plus 4 root 5. So we can say a is equal to 4 plus 4 root 5. So there's the value of a and b, and we've solved the problem. Now, a few things to note. One of the things is supposing we had chosen minus 4 root 5, and it didn't tell us that a and b are positive constants. Well, we know that they must be positive constants because if I put here a and b as a negative value, this will be undefined. So even though they didn't tell us they're positive constants, we must always make sure if that the values that we find for any variable in a logarithm equation must never cause a negative value inside the log. So you cannot have log to the base 4 of something negative or log to the base 4 of something negative. You can't have anything negative in these places. They can't even be 0. Okay, it's be undefined. So even though they told us this, if they hadn't told us this, we should have rejected b as minus 4 root 5 in this question because it would have caused this to be undefined. Okay, that's one point. Second point is, like for example, at the time of me making this video, the mark scheme hasn't been released yet. So if you want to make sure that you have got the right answer, okay, you can just simply substitute those values back into here. So a minus b equals 8. Does that work? Now, of course, that will work because you have 4 plus 4 root 5 minus 4 plus 4 root 5. So you end up with 4 minus 4, which is 8. And I'll just show you here. So just to make it clear, 4 plus 4 root 5. Okay, and you're going to take away all of, so I'll put it in a bracket, minus 4 plus 4 root 5. And you see what's going to happen here. You end up with 8. So these two satisfy this first equation. And do they satisfy the log equation? Let's see. We're going to log to the base 4 of a. And a is 4 plus 4 root 5. So log to the base 4 of 4 plus 4 times root 5. Okay, and we've got to add again log to the base 4 of, and we got here 4 minus 4 plus 4 root 5 minus 4 plus 4 times the square root of 5, and that should give us 3. If it gives us 3, we know for sure we've done everything right. So that's good. The values we got satisfy both equations, so we can be sure that we are correct. So in an exam, when you don't have a mark scheme to look back to check if you've got the right answer, that's always a wise thing to do. In case you made a silly mistake somewhere, to check that you have got the correct answer and make sure you get the full marks for the question. Okay, it's always a good idea to do that, to check your answers. So there's the answer to question 4. It's actually pretty simple. When some of the students took the exam, they were like complaining about this question because it's a bit different, but it's actually very simple. You have to just simply make this into, write it in normal form by using the laws of logarithms, and then it's a simple simultaneous equation, using substitution, and it's pretty fine. So a bit of fuss there, I think, for nothing. Anyway, that's this question answered. Other questions from this particular paper you'll find in the playlist, the link for which should appear in this region at the end of the video. Other questions from this particular topic of logarithms from P2, you can find the link for that playlist in this region here at the end of the video, and you can subscribe to my channel by clicking on the link in the middle. You can find other material that you might well be interested in from the other units of the Edexcel A-level, and also from IGCSE material in the description, okay, which is in the description. You'll see some links to that. Thank you for watching, and see you soon.